My name is Wale. I'm a GD in machine learning. During the day, for my day job, I actually work in the intersection of machine learning and renewable energy. And then during the night, I research machine learning for the developing world and also AI for social good. And today I'm going to be talking about how I'm using NLP and machine learning to understand parliamentary bills in low-resource countries. I think the first thing I'm going to talk about is what are low-resource countries. So low-resource countries are countries with low-income economy and also low-middle-income economy. And this name is coined by the World Bank and the United Nations. So one of the motivations for my talk came from the Open Data Barometer for Sub-Saharan Africa. So this is a data that is annually published by the WWF Foundation. And one of the things I saw is that in Sub-Saharan Africa, the average score is actually 14 out of 100. And this is based on the readiness, some implementation, and the impact. And then I actually went to Nigeria, which is where I originally come from. And I saw that the score is actually 21 out of 100, and they're ranked 70th in the world out of about 110 countries. And then going further, actually, I also checked the United Nations SDG. And one of the SDG goals that caught my attention is SDG 16, which actually talks about peace, justice, and strong institutions. And then I also looked at the SDG target and some of the targets, which one of them is to be able to develop some very effective and transparent institution. And also to make sure that when there is a decision making in government, that everybody is included and there's also some sense of responsiveness in that. And this led to a problem statement, which means how can we make sure that when parliamentary bills are introduced in low-resource countries, that the process of creating introduction and also the process where they want to analyze and process data, the average citizen can actually go and say, oh, I want to check the parliamentary bill, for example, from my constituency, and I also want to know what category this is. And the objective of this project is for us to be able to generate some semantic and structured data from the bills, and also we can categorize them into some labels that are socioeconomically driven. And the first thing we did is that we built NAS AI. So NAS is NAS stands for the Nigerian National Assembly. And what we did is we actually went from the Fourth Republic, which is from 1999 to 2018. And we scraped all the data from some website and some back server. And then we got all the bills that they have introduced. And we actually got about 2,400 bills. And what we saw was that the bills, they have different variety of quality. So you have this first one, which is a pretty good bill. The text are embedded in them, so the quality is good. And then we have another one, which is not so good. This is probably from maybe 2006. And we have this last one, which is really terrible. And these are some of the data sets that we have to work with. And I'm sure you guys understand that trying to clean and build a data set is the simplest part, right? Maybe not. And so this first bill is a bill to regulate local government elections in Nigeria. And the second one is a bill to prohibit the use of military during a live protest. And then the last one is a bill to provide free screening and treatment of cancer to the citizens of Nigeria. So what did we do next? We took this bill and we labeled them. We made sure that we chose 8 different labels that actually represents all the facets of government. And also they're really socio-economically driven. So for example, we have energy, environment, and natural resources. So one of the things we saw, we had a bill that actually wants to clean up the oil spills in the south-south region of Nigeria, for example. And then we thought, is this an environment bill or energy and petroleum bill? And we noticed it's the two of them. And then we actually put them together. And so this is the distribution of the different labels that we have. And then we can see that it's actually pretty imbalanced. And the first thing we did is to take this bill and put it into an OCR2. Because of the nature of our data set, we have to force some of our OCR choice. So the first thing is clean bills with embedded text. We could put them into PDF Miner and extract some of the text from it. The ones that are not so good, we converted them to images using PDF to image, and then we use the pre-trained OCR, the PyTesseract, to extract the text from it. And then the next thing is the pre-processing. So we took these bills, we removed numbers from them, we changed them to lowercase, and then we tokenized them, and then we removed the stop words, and eventually we tried to lemmatized to get some of the important words. And then we took this output from the OCR into a document embedding. So that means we use doc2vec to put them into some sort of vector. So we actually use the PV debow, so the paragraph vector and distributed bag of words. And for us to have the different class, and you could see the embedding space on the right-hand side. And so this is what our methodology looks like. The first thing is we take the bills. OCR2, we pre-process, like I mentioned, goes into a document embedding, and the best results we got so far is actually from a bidirectional LSTM. And so we have, it goes through the forward LSTM, then the backward LSTM, and then the outputs from these LSTM memories, we concatenate them, then to a dense layer, and then this softmax layer is to classify them with eight neurons, which stands for 8 classes. And we use LSTM because it could actually go in forward and backward. It could remember some of these memories better. And after implementing this, this is the result for a doc2vec and bidirectional LSTM. We had an F1 score of 0.71. We had very good results with health and agriculture. And I think labor, sports, and social welfare is not very good, and we have our confusion matrix there. So we also tried a lot of methods, and I'm actually showing about 3 of them to just show that doc2vec and BiLSTM is better. And we also tried Word2vec and a multi-layer perceptron. We tried TF-IDF with SVM because we know SVM is very good for high-dimensional data set. And so for doc2vec and BiLSTM actually beats other baseline methods. And so in conclusion, our experimental results already show that our model is effective enough to categorize this bill, which will eventually aid our large-scale digitization efforts. And also, our idea is that this result should have substantial impact for the different low-resource countries, and also for them to be able to meet open data charter principle, not for them to have some bills at the back of a server, for them to be able to get these bills, have it publicly, and be able to categorize them properly. So what are we doing next after this? Well, we're actually writing, we have a paper that we're going to submit to NeurIPS, Machine Learning for Developing World workshop that comes, I think, in December. And we're planning to extend this to 3 other countries in Sub-Saharan Africa. So we have Ghana, we have Kenya, and South Africa. And the choice of these countries are actually very strategic. One is they're actually English-speaking countries, so to make it easier for us to generalize our models. The second one is they have better metadata. So one of the things we want to do eventually is to see if we can build a very good knowledge representation of parliaments in Sub-Saharan Africa. So that means in Kenya, for example, we can get data apart from the bills. We can also understand bills that actually went into first reading, second reading, third reading before it actually passes. And hopefully we can build a model to sort of say, oh, this is, we have some probability that this bill is going to go into the next reading or the next phase. And also, we also want to build a custom OCR. We're thinking we're going to get people to label the data and also build something that we can extract very good data from the low-quality bills. And I think last week, Friday, we got some grants, which is from the AI for Development African Innovation Grants that would help us get people to work on this. Thank you.